Hi, this is Professor Stugard, and in this video we're going to be talking about data in the programming language R. So our goals for this particular lecture, first, what do I mean when I say that I want tidy data, right? When we talk about the package tidyverse, we talk about tidy data, what are we really talking about? What does that mean? The next thing we want to make sure that we talk about in this lecture, what are the basic tools we use to just investigate some of the basics about our data in our data sets or in our data frames. And then the last thing, we want to learn a little bit about the different ways that data is stored. And these are all things that we're actually going to be building on later on in the semester in probably weeks 3 and 4. So the first step to data analysis is obviously having data to analyze. So this means we're going to need to import our data into that R environment. There's a couple different ways we can do this, and raw data can come in many different forms. We're going to start this course by just importing our data from different packages. So remember, we have the CRAN, right, that whole network of different packages with tens of thousands of packages, and we're going to be using that to import our data in. Later on in this course, we're going to talk about how I can import data from my own CSVs, and then even later on we'll talk about how to scrape the web for data too. But for now, we're going to start with just our packages. Now, one of the most important things is that we want our data to be tidy. Now, tidy data is typically stored in a data frame, which is sometimes also called a tibble in the R programming language. So if you see tibble really means data frame, which really just means basically like a spreadsheet. All right. Now, there's going to be 3 rules with our data that will make our data set tidy. First, every variable has to have its own column. So again, think about a spreadsheet. Each column is going to be its own variable, like names, locations, ages, or something like that. And then each observation will be its own row. So each row is going to belong to its own specific observation, which has a value for each of those different variables that were in my columns. And then each value needs to have its own cell. And so, again, you're going to see when we import lots of data sets or when you start getting data sets from other places, well, they will be untidy in a bunch of different ways. And it'll be our goal to make it tidy before we can do our analysis. So again, tidy data, your variables, and again, if you can see what's written there, like country, year, cases, population, those are all my variables. They're each listed as their own columns. And then we have our observations. So each row would be our own observation. So like each country with the year and the cases and the population. And then each value needs to be separated into its own cell. And again, you'll see that that does not necessarily happen all the time, and we'll have to work on different ways to kind of wrangle our data or tidy our data before we can do good analysis. And again, this is all stuff we'll build on as our semester progresses. Now, the first step is once I have my data imported or I have my data set, I want to know a few basics about the data that's going to help me to start working on it. And we have several functions that are going to help us do that and to help us kind of gain our insight. So first of all, when we load our packages, most of our packages and data sets have their own descriptions. And by using the help function, by using that question mark, we can actually get some of the basics out of the way and understand what the point of this data set was to even begin with. And so again, in your console, you do question mark and whatever the name of that particular data set is. More functions that we can use that would be kind of nice and help us to know what's going on would be to look at the first 6 rows. Right? If I can see the first 6 rows, I can get an idea of kind of what's going on. What are my columns looking like? What are each observation looking like? And again, kind of just to get a feel, get an understanding of what the huge data set looks like as a whole. We can also figure out how many rows there are. And again, in tidy data, each observation is supposed to be its own row. So the number of observations should hopefully equal the number of rows if it's tidy. And that would be the function nRow. All right. And then if I want to know how many variables or how many columns there are, that would be n columns. And again, n is, again, typically one of those things that tells us that we're counting. We use n as our counting number for the natural numbers. And so each of these are functions. All right, and you can see that head, n row, n column, those are the function names. And then each function has a parentheses. All right, and then that's where we would type in our data set. And that's basically how all functions are going to go. Our functions are typically verbs followed in parentheses by what the function is going to be applied to. So again, this isn't a real function, but this is how most of them are built. Do this, and then in parentheses, to this. And that's the main idea behind our functions. All right. So again, with each of these functions, like again, head, the function says, all right, do print out the first 6 rows, and then in the parentheses part, to this, well, to that particular data frame. Now, there's other tools we can use to explore the data as well. If I load the Dipler package, which is part of the tidyverse, I can actually load the tidyverse, and if I do tidyverse, the Dipler package is in there as well. And again, we'll talk more about packages and all this stuff later on. But a very useful function is also the glimpse function, because the glimpse function is not just going to show you, well, it's going to show you lots of things, but one of the important things it's going to show you is it's also going to show you how the data is stored. All right. Now, again, you'd have to load that package first. So again, the library Dipler, well, install.packages tidyverse or install.packages tidyverse in quotes, then library tidyverse or library Dipler, and then we can do glimpse, use the glimpse function on our data set. The nice part about the glimpse function is that it's going to tell you what type of variable is being used in each column. And again, this is something we're going to build on later. So again, just kind of an introduction now, and we're going to see these things keep repeating themselves over and over and over again. We're going to basically spiral through the same concepts, getting slightly more complicated each time we look at them. And so it is important that we know what kind of variable is being used. So int stands for the integers or the whole numbers. All right, so in that column, you only have whole numbers, right? No fractions, no decimals allowed. If you do want fractions or decimals, then that's called a double or a numerical. And so DBL stands for double or the real numbers where we have decimals. CHR stands for characters or strings. So that would be something like a name, like Professor Stugard. In quotes would be a string, and that would be stored as kind of a character. LGL stands for our logicals, and our logicals are either true or false. It's kind of the Boolean algebra there. It's either true or false. It's either a 1 or a 0, on or off. Those are our logicals. Factors, and again, these are all things we'll get into later on. Factors represent categorical variables with fixed values. So if I had a data set with, let's say, different types of pets, well, the type of pet could be a factor because it's either going to be a dog, a cat, or a bird. I have a fixed set of values for that particular category. All right, and that would be a factor. And then we can also obviously store dates or date times, which is the date plus the particular time as well. And those are the main data types, and we'll explore these more in depth as the semester progresses. And so, the conclusion. Can we answer the following questions? Number 1, if a data set is tidy, what does each column represent? Good idea. Well, then what does each row represent too, right? What function would I use if I wanted to determine how many observations are in a tidy data set? So if I know my data set is tidy, what function would I use to determine how many observations there are? And lastly, what type of data set, an integer, a character, etc., would be the most appropriate way to store the following variables? So what about ages, right? If you're storing the age someone is, how many years they've been alive, which would be the most sensible way to store that? What about names? What would be the most sensible way to store names? Right? Would it be a logical or a double or a character? What would be the most logical way to store it? Which would probably not be a logical. And what about textbook prices? Would we store textbook prices the same way as I stored people's ages? Why do you think so? Yes or no? All right. And again, if you don't know the answer to that question, that's fine. Well, scroll on back, rewatch the video, and make sure that you can answer these questions before we move on. All right. And as always, take care of yourselves.